Okay, 2.1 forces and free body diagram. So from grade 11, we have done some free body diagram for forces. For example, if you have a book sitting on a table or sitting on a surface, the forces acting on this book is gravitational force, F of G, and force of normal, F of N. Since in Y direction is no movement, right? Summation of these forces add up to 0 because something is not moving. You already know force is equal to ma, right? If you add all of the forces in Y direction is equal to summation of the forces is equal to mass multiplied by the acceleration, mass of the object multiplied by the acceleration of the object. Since in Y direction, there is just the no movement, summation of the forces in Y direction gonna be what? 0, means that is not moving, velocity is 0, acceleration is 0. Therefore, F of N, which is positive, and F of G is negative, is downward, right? Is equal to 0. From that, you can conclude that force of normal is equal to force of gravity. So in this case, since it's not moving, force of normal is the same as gravity. But let's say you're in elevator, it's going to be a different situation. We'll get to that. So here is the force of gravity, force of normal, force of tension. Let's say you have an object is hanged from the ceiling. What force is acting on this? There is a tension force. So make sure tension is out of the object toward the rope. So F of tension is like that. Out of the object toward the rope. You just remember that. And you have F of G. Again, since in Y direction, this is not moving, so acceleration in Y direction is 0. These two forces need to be equal because they are in opposite direction. They need to cancel each other. So in this case, when it's not moving, F of T is equal to F of G. But if the case is that I'm just taking that up with some acceleration, these two forces are not going to cancel each other. So we'll get to those questions. Any question? Okay. So here is another situation. Look at that. You have a object hanged on. It's connected to the wall. So we have a rolly here. So there's a tension out of the object toward the rope again, F of T. When it's connected to the wall, there's going to be a tension out of that, right? These two tension are the same since this is a rope is connected to each other without any break, right? So this is just a consistent rope. This FT and this FT is the same, and we have F of G downward. Since if it is not moving, again, we consider these two forces canceling each other the same. But not always. Here in this situation, we have again friction. Friction is when an object is moving on, this is my object, this is, let's say, is moving with constant velocity or is moving with acceleration. It's just moving, right? It has a kinetic friction and it's against F of friction kinetic and it's against the movement. If you're pushing, you apply the force, but is not moving, means you cannot overcome the static friction. There is also friction, but we call it, which is against the direction you're pushing. F of friction is a static here. Okay, we'll explain that more, but just knowing what is the friction. Okay, here you toss a ball vertically upward, drop PD in a ball just before to leave your hand. When you throw something, you're pushing that up, right? When it's in your hand, you're pushing it. So you are kind of, you have a apply force. Here they said normal force upward. And of course, the weight of the object is downward. Any question, Jason?
No. Yeah. Let's understand that. Yeah.
Perfect. Okay, a triad. So anytime you have question, please ask. A triad is pushing with a horizontal force against a chair that remains stationary. Draw a system diagram. So is it pushing forward? So you have applied force. Since it's not moving, so you have a static friction against the movement, F of S. Also, you have force of gravity downward, force of normal upward, because it's on the ground. So on ground is pushed that up, means you have normal force. So this is about the free diagram. Okay, there's another case that a person is moving on inclined surface. I'm gonna draw an inclined surface and explain that to you. So let's say this is an object and is moving upward. There is an angle here. For y direction, conventionally, we take the y-axis to be normal to the surface. So here gonna be my y-axis, normal to the surface or perpendicular to the surface. And here gonna be my x-axis. And all of the forces, I'm gonna put that, we need to do it respect to these two lines. Gravity is downward toward the earth. So this is gonna be my F of G, right? Normal force is just perpendicular to the surface. The surface pushed that up, right? So it's F of normal. We have F of applied. This child is pulling that. So F of apply or F of T, because it's a rope. So when you pull with F of apply, so it produces tension in the force. I can put that as a tension. This tension and apply force is the same because just the rope is consistent. And here is force of kinetic friction. Force of friction kinetic is against things. Now be careful. F of T is in x direction. F of friction is in x direction, in negative x direction. F of N is positive x direction. But your F of G has two components, right? X and Y, because make an angle with the Y axis. I need to find the angle. So since I know this is 90 degrees, right? This angle here going to be what? 90 minus theta. So since the whole thing here is 90 degrees, therefore this angle gonna be theta. Got it? Next time you're doing the question, when you have inclined surface, just remember the angle that your gravitational force make with y-axis gonna be the same as theta, inclined, the angle of the inclined surface. So since opposite is sine, so this side, which is x direction, this is gonna be F of gx. F of gx, and here gonna be your F of gy. So fgx is equal to F of g multiplied by sine theta, because opposite is sine.
Yep.
And F of g in y direction is equal to F of g
In cosine. Yep.
cosine theta, right? So we will do lots of questions based on this. So you better just, if you forget, go back to this question FBD diagram. Any question?
No.
So here are.
You want me to practice any?
Okay, so just question number 4.
4.
Page 73.
Yes, I got it.
Okay, analyzing forces on a stationary object. A stationary object means an object is not moving. Hitting volleyball, a player apply an average force of 9.9 Newton 30 degrees above the horizontal for 5 milliseconds. The force gravity on a ball is 2.6 down. Determine the net force on a ball as it being struck. So the net force means you have to add these two vectors, right? So this is 30 degrees to the ground, 9.9, and here is down. So you know this f of apply has two components, x component and y component. So you need to find the f of apply x component gonna be your adjacent. That's why it's 9.9 cosine is adjacent. Cosine 33 and y is your opposite angle side to this angle. So it's gonna be sine 9.9 sine 33. So you find the x and y component of f apply. Then for f of gravity, you just have y component, means x component is 0, y component is negative 2.6. So you need to put them together, add all of x components, add all of the y components separately, then put that together using the Pythagorean theorem here. And then you want to find the angle, use the tan to the y component or x component. Here you got an angle 90. So this is the pictogram of that. So your phi is 90 degrees. So this is your y component here, your x component for the total force. We have done the addition of the vector, but do you have any question?
So I have a question. So for the F to Y, I don't know why it's the minus 2.6.
Okay, because this is downward. So because it's south, right? Anything south is positive, north is we did south and up. Just make sure that here y component, this if it is up, so it's going to be positive. When it's down, you have to make sure it's negative. And to the right is positive, and to the left is negative. Okay, so it's downward.
Yeah. Yeah.
Perfect. Now here is another question that you need to add or subtract the vector. Let's say the boat to figure 10 is secured like side pier with a 2 horizontal rope, a wind blew offshore. The tension in rope F1 and F2 is given. So there's 2 rope attached to that, so we have F1 and F2. There is the same angle that we make with the x-axis 48 and 48. Use a vector scale, determine the sum of the tension. So you just need to addition of these vectors. See, their y component, both of that has a y component, right? Because they have the same magnitude and same angle with the x-axis, these two y components cancel each other. The only component add up, both of them is on x-axis in the same direction. Their x component gonna add up. So you do the same thing. You find the x component and you come the y component, but make sure the y component of the F2 is negative. So when you add these two, it would be what? 0. You find the x component of both is positive x component, so you add them up. Again, you do the same things, true? Add x components separately, add y components separately, put them together, Pythagorean theorem, and there you go. That would be, and then you find the angle. But here you don't need to find angle, you know what's gonna happen. It add up in x direction. And your answer just gonna be in what? Why they put the west here?
Because this side is positive.
But here is, oh, the wind is pushing. Okay, let's just read the question one more time. The wind is blowing offshore, tension in the rope. Okay, so yeah, so use the vector there to determine sum of the tension. So the first one is just do the sum of the tensions. And the second one, assuming that the net horizontal forces on the boat is 0, determine the force of the wind. So basically the force of the wind is opposite to the force that you find. That's why. I know the summation of these two forces is going to be in east, but the wind canceling, these two forces canceling. The wind should be to the west, true? To cancel with this. Any question?
No.
Okay, so that's it. Okay, you do question number 9. This is page 75. And question number 11, this is 76.
Yeah, I got it.
Okay, so